Okay, so we are now looking at inventory management model 2, which is also called the production model, or we can say the lot sizing model. Lot sizing simply means we are in production. We don't want to continue buying from our suppliers because we can make our own goods. So now here we're looking at how many units can we produce at on a daily basis, and how many units are demanded on a daily basis when you're looking at production. So under this one, we want to find the batch size that we can produce. Okay, and then looking at the question here, the build up of yesterday's class, we are looking at XYZ company produces units of the commodity, and that their annual demand is 50,000 units, and annual production is 75,000 units. From here, we need to know how many days the company is taking to operate. So the question says the company operates 250 days of the year, meaning other days they are not working. Maybe Saturday and Sunday, or even holidays, they are not working. So we can use the number of days here to actually calculate the daily demand from there. And then we can also find the daily production because the number of days we have been given. Now, the setup cost is at 350 kwacha. This is the setup cost, means the cost involved in setting up items for production. Maybe you clean up the equipment, you hire items from somewhere else because you want to produce your own goods. So this is the meaning of setup. The unit cost or acquisition cost, this is the unit cost or acquisition cost. The unit is at 35 kwacha. So we can acquire a unit at 35 kwacha. And the carrying cost is 10% of acquisition cost. So I have to make mention here that carrying cost is always the percentage of the unit price as we are in production. So we need to determine the economic load size. How many units can we produce at a time? In example 2, yesterday we did the model 1, and we're getting down to model 2, which is for the production model. And we need to build up, get into the last model, which is the discount model. All right, then. So determine the following: the economic load size, which is the batch size, how many units we can produce at a time, the number of production runs, how many times can we produce, the length of production run, the cycle time, the maximum inventory level, and then we get to the total stocking cost, total material cost. All right, so this is the formula that the examiner is likely to give. So economic load size, we're talking about 2ds over c multiplied by p over p minus d. P is our daily production. This one, we're talking about daily production. So this is our daily production. This is our P. So we're saying this is our daily production, and then the other one is our daily demand. So this is what we are. So here we have the daily production, and then the other one here we're talking about the daily demand. The small d is the daily demand. So when you understand these models, then it will be very easy for you to understand even other questions that come in an exam. So from the question, we can see that we have the information there already. So we can find our daily demand, which is annual demand, which is this one, divided by the days of the year. We are getting 200 units. Then we are getting our daily production is annual production divided by the days of the year. So we're getting the 300 units. So current cost, like I mentioned here, is the same as holding cost. So we're simply talking about the cost of paying warehousing salaries and wages. We're also talking about the cost of insurance, paying interest rate. I think actually even those people who man the stock in a warehouse, actually even paying for the floor space charge related to the warehousing activities. That is what we look at the carrying costs. So carrying costs involve all those costs. So now here we can now go back because we have the annual demand from the question, which is 50,000 units. The 2 here is constant. So this two is a constant number. It's just part of the equation or part of the formula. Then we get to the ELS, which is the economic load size. So P, we know is our daily production. Small d is our daily demand. Then we can actually sort out here, and we are getting our economic load size as 5477.22. Okay. So this is what we have. So we have 5477.22. This is our economic load size. Okay. Now, from getting the economic load size, we need now to find, because the current cost we calculated is just the 10% of the unit price, which is 10% of acquisition cost, which is 10% of 35. Where we are getting our economic load size as let's say the current cost as 3.5, plus 10% of 35 kwacha, 3.5. Then after substituting the formula here in the equation, we got the economic load size, which is 5477.22. This is how much we are able to produce at the time, because if we are in production, we don't want to continue ordering from suppliers. Now, once you get the economic load size correct, means that even other questions coming down, we will be able to get them correct. This is what happens in this inventory management as we're looking at model 2. So the catch here is to look at which model are we talking about. For as long as I've mentioned about the producing the units, you know that it's model 2, which is inventory management model 2. Then we're getting down to the other question here. We are looking at how many times can you produce, number of production runs. How many times can we produce to meet the annual demand? How many times can we produce in a year to meet the annual demand? That's what it means by the number of production runs. So in meaning here, the formula is just the Q, which is the annual demand, divided by E, or this is economic load size, the one which we have already calculated as per this one. So that's why if this one is wrong, you get the number of production runs wrong, and then the other parameters may also be wrong. Okay, so we are getting to the other one here, where we're saying the length of production run. So it means how long are we taking to produce a batch? Because we are looking at it per day. This is how much, this is our economic load size. So we are looking at this one as economic load size. And then this one is our P. So this is on a daily basis. We are able to produce 300 units. So meaning that we can know how many days we are actually taking to produce a batch. Okay, so on a daily basis, we are producing 300 units, but we need to, how many days would take for us to produce the batch, which is on the batch basis, the economic load size is 5,477.22. That's the batch in units form. So these are units that we are producing. Okay, so now we get to this other one, length of producing a batch. So we are saying it's 18.2574 days. So that's the length of producing, that's the length of production run. Okay, so we are getting 18.2574. Now, when you get to cycle time, this is the time between production run. So it is Q, which is the economic load size on top here. So we have economic load size. Then you divide. Yes, please.
Sorry to interrupt a bit. When we're looking at the length of production run,
Yes.
Q over P. What's the P?
The P is our daily production. So this is the daily production, which if you can see here, it's here when finding it, it's here. If you can check out, this is how we find our daily production, which is our P. So it is the annual production from the question divided by the days of the year. All right. Okay, then. So now we move on. So it starts from here that you build up from here. So you're getting to as you can see, after substituting in this equation, we got our economic lot size. This is lot size simply means production size. That's the meaning of lot size. We are in production now. So from here, you can check the information, get the annual demand, and all that to divide by the number of days of the year to get the daily production, or be it the daily demand, you're dividing by the number of days of the year. Then, of course, here, when you come across the same day or the term setup, it means that we are in production. So we get to the other information here, where we are looking at, since this is the batch we are producing, but on a daily basis, we are producing 300 units. So how long are we taking to produce a batch? That batch, that's the production. So that's why we're getting 18.25 days. The cycle time is simply the time between production runs. So now this is Q is our ELS, this D is our demand, annual demand. So multiplied by the days of the year. Now, you are supposed to be very careful. In the exam, sometimes they'll give you the number of weeks of the year. So if the annual demand doesn't, the days of the year are not given, you use the 365 days. Now make an assumption that if the question is open, you get the 365 days, but they will specify in most exam papers. Because the examiner will not want to start having difficulties to mark, because somebody can get 52 weeks, or others can go for 365 days. So they will give you the specified days. So you say Q over D, which is annual demand, multiplied by the days of the year. Days of the year in this question paper, in this one, in this example, the days of the year, we have 250 days of the year. So we're going to find the cycle time between production runs. So we're getting this one over the annual demand, which is 50,000 multiplied by 250 days. So we're getting 27.386 days. That's the cycle time. All right. So we get to the maximum inventory level. So maximum inventory level, the formula for this one is P minus D multiplied by Q over P. Now this one, it is the period of delivery. That's the meaning of this one. This one is the period of delivery. And then the build up, this one is inventory build up, which is this one. So when you are looking at maximum inventory level, you look at the build up of inventory. To build up on inventory simply means the daily production should be more than the daily demand if you are to survive in business. Because if people come to ask for a chicken, if you sell chickens at home, then you tell them you don't have, because which means that the demand is higher than your production. Okay, so even tomatoes, you sell a box of tomatoes and people come to ask for a box of tomatoes and you don't have any, they'll run away, they'll go somewhere else. So your build up of inventory should be, our daily production should be actually be more than daily demand if you are to survive in business. So that you see how you progress. So this is how you get the maximum inventory level. Is about build up of inventory multiplied by Q over P. The Q over P, it is just the same as this one here, the length of production run. So Q over P is the same as the length of production run, but it's also called the period of delivery. So here we have our P. We can go back and check for it because we know our P is the 300 units and our D is 200 units. So you can substitute there and get whatever is supposed to be. So this is 300 minus 200. Then this one, the Q is the ELS. So this is our ELS, which is economic load size, and this is our P. This one is our P. So we can actually sort out. So the maximum inventory level, we are getting 1,825.74 units of the commodity. So the buildup of inventory is 100 units. So if it asks you to say what is the inventory buildup, so it is actually daily production minus the daily demand. Then if it asks you to find the period of delivery, which is also called length of production run, this one also called length of production run, it is 18.2574. Now, since we are in production, so we are going to look at what we call the total stocking cost. So this total stocking cost, it's management costing we're talking about now, because we are looking at the cost of holding stock and ordering. So in a shop, you look at how many units have you ordered today and how many units did you carry from yesterday? Because if yesterday your close of business of inventory was a certain amount of stock, then today you ordered some stock, then your total stocking cost will be the annual carrying cost. So this one here is called annual carrying cost with production. So this is annual carrying. So this is annual carrying cost. So annual carrying. And then the other one is annual ordering. So this is annual carrying. And then the other one is annual ordering. So this is annual ordering. So this is annual ordering. So you have actually two costs that are involved here. You have annual carrying and annual ordering. So all this, so you just have to substitute the Q. We know so what we have found already. The 2 is constant. This one is a constant number. Then here we know what is going on. P is 300. The D is a 200. Then a P is a 300. Then our C, we already calculated it because the carrying cost is always the percentage of unit price. This is carrying cost, or it's also called holding cost. So holding cost and carrying cost, these are one and the same. So holding cost or carrying cost. So it is just the percentage of acquisition cost, or it's a percentage of the unit price. So there are two combinations that are there. It's a percentage of carrying cost or acquisition cost. Okay, carrying cost. So we get to this one here. So we are finding, after substituting here, as I mentioned, in the area in the model 1, which is a purchasing model, that the annual carrying cost and annual ordering cost, the answers are supposed to be almost the same, if anything, the same. So that's why you're getting the 6390.10. After you calculate here, this one, you can compute and confirm the answers for this one and this one. Then you're getting the total stocking cost. This one I have to emphasize, when you're doing stock taking, you should look at what have you ordered today in the shop, then plus what you brought from yesterday before you ordered. So this is annual carrying that you carried from last year, 2021, an example, then plus what you have ordered this year. So that is the total stocking cost, because you're looking at what you have ordered and what you carried. So this is what is going on. Then you get the total material cost. Total material cost, you just simply get the total stocking cost that you found, then with additional that component. This component is not found in the TSC. In the TSC, the total stocking cost, that component is not found, this one. So this is the unit price multiplied by demand. Then of course we know the unit price. You can go back and check the unit for the unit price. The unit price here is 35 kwacha, which is acquisition cost per unit, which is the unit price. 35 kwacha. Then you multiply by our annual demand. In this case, we know annual demand is 50,000. Then here this is an addition. Then we are getting the amount of total material cost of 1,756,390.103. So this is what you expect as you are looking at model 2, which is the production model. So this is just what is involved in model 2. So if you can go to the pamphlet, you can see that there is a question similar here that needs to be looked at, because here, since we have looked at model 2, so we can get into the pamphlet before we get to, because what is important is to understand the concept, because I know we need to have time also to go through as many question papers as possible so that we can understand thoroughly. So there's this question here for in production, so that you understand this one thoroughly. Because question 4, if you look at question 4 of this pamphlet, we're talking about Book World. So they're saying Book World, the publishing company, produces books for a retail market. So meaning there's this item here. This is a pamphlet for UNLAS here. These are questions that are recycled. Okay. So there's that term, they are producing that. So you already know that this is model 2. All right. Similar to the question that I gave you there, the one which we are from looking at right now. Now, demand for a current book is expected to occur at a constant. So we have this is demand. The cost, this is acquisition cost per unit, which is 27.50. Holding cost is 18% annual rate, which is mean 18% of this amount. So it should be 18% of 27.5. And then the production setup is it. So this is setup cost, which is our S. So this is it. You come across, this is our S, which is 550, because we are setting up for production. The equipment on which the book is produced as annual production. This is annual production of 21,000 copies. So you mean you need to understand the concept. So annual demand is this one. So meaning you can find the daily demand. Okay, so this is our annual demand. We have that one. So you can find the daily demand simply by, so we are supposed to, a company uses 250 working days, similar to the one I gave, the one which is there. And the lead time is 12 days. Okay. Assume the company is willing to tolerate a one stock out. So meaning you just say, okay, according to what you have produced, if we run out of stock once, it's okay. Because at least people will actually tolerate that, to say, yeah, today you've run out of stock once, it's better. And then they're saying that the lead time demand follows the normal distribution with a standard deviation of 75 copies. All right. So using an appropriate fixed order quantity system model, compute the following values: minimum production load size. So when you come across the term load size, means you are in production, you don't want to order at any possible time. So what goes on here, and then here number of production runs, which is you go to the similar to what we're from looking at, and then the cycle time, the formula is there because the days are given, length of production run, maximum inventory level, order point, safety stock, total stocking cost, all that. So solution here, if we come here, this is supposed to be economic load size. Okay, not order quantity, it's supposed to be economic load size. So in exam, we write economic load size. So this one supposed to be cancelled. So 2ds multiplied P over C, P minus D. So you substitute. How do you find the daily demand? So this one, you divide annual demand, divide by the days of the year. Okay, so this is how you find the daily demand. That you should do actually come one day, put here. Then our P this is what is going to happen. You also divide, you get that. So that is our day production, which is there because the annual production has been given here, the question. So you just need to calculate those ones. After you calculate those ones, then you can substitute there, and then you sort out this and find the square root of it, and they found the answer as this one. The solution is there already. So this is the answer for economic or economic load size. So we have this one, economic load size. Okay. So now what goes on? You find number of production line. So it's D over Q. D is annual demand, which is 75 divided by what we have found already there. Excuse me. So this is what goes on. So we have found 4.66 rand. So this is how many times we can produce. Okay. Now, from the statement, they have mentioned that we can tolerate one stock out per year, meaning that from how many times we can produce, even if we don't produce one out of this is okay. So even if we don't produce one out of this amount, how many times we can produce to meet the annual demand, to number of production runs per year. So one out of this, even if we don't produce, we are running out of stock once. So meaning one out of that amount is okay. So we'll come back to it as we are getting down. So this one is the first answer. This one we get to, now we get to the cycle time. Cycle time we're talking about, so it's the Q over P. So here, so it was supposed number, so it's supposed to be Q over D, okay, then multiplied by days of the year. So this is multiplied by the days. Okay, days of the year. So multiplied by days of the year. So you are going to calculate this. So the answer you found was this one. So meaning this one, okay, so it's Q, which is you use the same Q, which we found here, 1610.15. So that's what you do here. 16, so 10.15. Then you divide by D, which is 75. Then you multiply by the days of the year. So 75 here. Then multiply by 250. So this is how you get to the cycle time. Of course, even here it's okay. So even if this formula is okay, but this is a common formula that we use for calculating to calculate the cycle time. So just use this one, calculate the cycle time. But even this one is okay. It will still give you the same answer. When you divide this and multiply by this, you can calculate to give you the same answer there. Now, length of production run, which is Q over P. So meaning, how many days are we taking to calculate, in fact, to produce a batch? To produce a batch, how many days are we taking? So it's just Q, which we have found, over P, which is a day production. We divide 19.17 days. Then you find the maximum inventory level is equal to inventory build up, or we can still go back to the other formula I gave you, which is P minus D multiplied by Q over P. Okay. So our maximum inventory level here, it is you can, in fact, what happens here is that we actually, this SS, they included, because in this question we had the safety stock units, okay, because of there's a probability of stock out. So in this question, at the build up, it was a detailed question, so to speak, because at the build up, because of there was a stock out. So there was, and in fact, there was even another information to do with the normal distribution, the standard deviation of that amount. So this SS was included here, which is a safety stock. SS is called the safety stock. That's why here the maximum inventory level due to safety stock. So this is a safety stock, so it changes. So you can go for this same formula here, because here we have aspect of safety stock. So you can use the EOQ here. P, we know it's a daily production minus a daily demand over P plus a safety stock. Now, safety stock is a buffer stock kept. So this one is just a buffer stock kept for security reasons and is calculated by. So this is the value for the safety stock. It's a Z value multiplied by standard deviation of demand. So the Z value, it has been obtained using the probability. So this Z value, first of all, we need to find our probability. So this probability here, we need to know our probability is equal to, so this is the probability of stock out, first of all, which is equal to, so it is equal to 1 over 4.66. Now this 4.66 is coming from where? It's coming from here. So we are using this one. Okay, we are saying that number of production runs, we can run out of stock once. We cannot produce once. So that's why this one comes all the way here. So you can find it, if the cosine, it will give us it. So you can divide that one. Okay. So we are getting the 0.0.214, just about 46 somewhere here. This is our P. So when you find this P, when you use the normal tables, you can find the Z value corresponding to this one. Or yes, you can even get the table. So we can find the Z value corresponding to that one, which are the normal tables. To the 0.0. Okay, so just hold on. So here we can find, so it's giving us, okay, if you're using the cumulative tables, you need to subtract, get a 1. Get a 1, so using the cumulative tables. So if you're using the cumulative tables, you can simply just get a 1. Okay, cumulative tables, just a 1 minus the 0.2146, because I know UNLAS, they like using cumulative tables usually. So you need to just get that one. So we are getting the 0.8. So find the Z value corresponding to the 0.7854. So meaning that that Z value is the one they found here. Okay, so you check for this one from the cumulative table, it should give you that Z value, which is the one they used here, and then they multiplied by the standard deviation of daily demand to get the safety stock. So from the quantitative method, the QM, you can see that here, since they use the cumulative tables, so you can check for this one, look for it one, just find the Z value corresponding to this probability here for 0.7854. Then it should give you the 0.79. So if you are cumulative tables, you can check for cumulative tables, you get that Z value. So our safety stock will just be this one probability. So here, because we are the one stock out, which is this, but don't use this one unless if they give you the normal tables, you can still check to give you the same ones. And then if you're using the cumulative tables, you get this one. So they got the 0.79 from using, I'm sure, every cumulative table, whichever table, but I'm sure since they use cumulative tables, so you use this one. So the 0.7, Then multiply by standard deviation of demand, which has been given here. Standard deviation of demand is 75 copies. So our safety stock is equal to Z value. So Z value multiplied by, so here they even found it. Probability of stock out is this one. They found it, which is the same one. They found the probability of stock out, which is it. The one similar to this one, 0.214. So 1 over this. So you can still check for this one from the normal table, or you can get the cumulative table, subtract from 1, then you get that one. So our safety stock is equal to Z value multiplied by standard deviation of demand. We're getting this one. So our maximum inventory, we can come here and put our EOQ, which is economic load size. So this is our economic load size, which is equal to the one we found. The P was our daily production minus our daily demand over P plus the aspect of safety stock, which we have calculated here, 59.25. So we substitute there in this formula here. So we are getting maximum inventory level. This is due to safety stock. So this is due to safety stock. So we are getting, so due to safety stock. So meaning we are actually getting that maximum inventory, which is this one. Now, from here, we need to build up to find the other question says we need supposed to find the order point. Okay, so order point. Okay, so we need to go and find it. So it is first and foremost, we know the order point. Our order point is equal to expected demand during lead time, then plus our buffer stock, which is the safety stock. But the safety stock we have already calculated. So our demand you expect during lead time. So it is daily demand multiplied by lead time. Yeah, so this is our expected demand during the lead time, then plus our safety stock, we know we found it's 59 point what? So we already found the safety stock of 59.25. So this one is 59.25. So we just need to find our expected demand during the time, which is daily demand. We know it is daily demand is 30. It has been already calculated here. We found our daily demand using the aspect from the information here, which is this one. So 30. So this is why if you put 30 here, daily demand 30, then multiplied by lead time.